Okay, you're into 5.14, 5.14. There's two things I want to do. I want to review 5.13, and then I want to springboard into some new content 5.14. So this is review, but it is also mandatory to do this to get a grade on this. So I want you to pause and review. How would I do A, B, and C? Okay, take a minute, take 5 minutes to go ahead and do this on your own. Check back in with me, unpause me to find the answer. Okay, I'm going to review this. Maybe you've done this on your own. Maybe you're waiting for me to explain it. But the position of a dog moving along a horizontal line, I know this is weird to think about a dog moving back and forth, is given by the equation x of t equals negative 2t to the third plus 24t, where x is in yards and t is in minutes. I'm going to annotate some things here. So x is in yards. So this is kind of my output is going to be yards, my distance, right? Where t is going to be my time. And what is that in? And that's in minutes. So I know that my units here, we're talking about yards and minutes. Okay, so it asked me first, what is the position of the dog at t equals 2? Indicate units of measurement. Well, what does my equation tell me? Does my equation tell me the position of the dog? Yes, the position of a dog. So my original question is actually telling me, use this formula. This is how you're going to find the position of the dog. So we're going to plug in x of t when our t here is 2. And we're just going to plug that 2 in. So negative 2 times our t, which is no longer, that's going to be 2, raised to the third power, plus 24 times that t of 2. Okay, we can do this kind of work in our head. I know I would do my exponents first. So this is going to turn into negative 2 times 8. Plus, what's 24 times 2? That's 48. And then here, let's just kind of do some work in our head here. Our calculator, negative 16 plus 42 is 32. Right, that's our answer, but what did it ask me? What is the position of the dog at t equals 2? So if I have an input of t2, 2 seconds, this formula is telling me the position of the dog in terms of yards. So it's going to be 32 yards. And remember, a positive position, right? This tells me how far away that dog is, maybe from the start. All right, so 32 yards away, perhaps. Okay, what about part B here? Part B doesn't ask us for the position. Part B asks us for the velocity of the dog. Well, they don't give us a velocity. What am I going to do? Come in here and like chart after every single minute how far that dog is, and then take the rate of change and divide, distance divided by time to find that velocity? Sure, I could do that. I absolutely could do that. I could find the average rate of change, right? Between maybe a time of 1 second and a time of 3 seconds, or a time of 1.9 seconds and a time of 2.1. This is all a lot of work, and it's all going to give us an approximation. So how do I find velocity? Now, yesterday we talked about this. So if you missed 5.13, this is what we talked about. In order to take the velocity from a position function, we're just going to take the derivative. We're going to take the derivative of our original function. So we're going to find x prime of t. And x prime of t is really just the same thing as the velocity. Why is that? Because derivative tells us rate of change. Derivative tells us the rate of change. I'm taking the rate of change of position, the rate of change of distance. That's distance in regards to time. That is velocity, distance over time. Find the derivative, find the rate of change. Find the derivative, find the velocity. That's what we're doing here. So let's take the derivative using the power rule. So let's use that power rule up top here. Bring that 3 down and multiply. And then I'm going to subtract 1 from that 3. That's how we use that power rule. So if I bring that 3 down, I'm going to have 2 times negative. That's negative 6. Keep the t, subtract 1 from that exponent. That becomes a 2. That's our use of the power rule for derivatives. I'm going to do that for the second one too, 24t. Bring that 1 down. That stays 24. Right, but then it becomes t to the 0 power. I'm not going to put t to the 0 power in there. T to the 0 power is just 1. I'm going to leave it. So it kind of disappears. When I get to an exponent of 0, we kind of think of that as disappearing. So this is my derivative function, which is good. This tells me velocity. Let me just kind of annotate this, right? This is my velocity function, which came from the derivative. Okay, so why is that important in this problem? Because they ask me for the velocity at t equals 2. So let me put some spaces in here. And I'm going to say v of 2 equals negative 6 times 2 raised to the second power plus 24. Let's kind of do some work in our head here. That's going to be 2 times 2, which is 4, times -6 is -24 plus 24. That's 0. Meters per second. Notice how I put that label in there. Okay, because it says indicate units of measure. Okay, 0 meters per second. So this dog isn't even moving after 2 seconds. It's taking a nap, hanging out, maybe changing direction. I don't know. It's got 0 meters per second of movement, 0 rate of change there. So given our position, we can take the derivative to find velocity, and then we can actually find the velocity at that particular moment, that instantaneous rate of change, which in this case is 0. Okay, that's parts A and B. Now part C is a little bit different because part C asks us for the acceleration. Well, what do you know about acceleration? Acceleration is the change in velocity. So if we find the change in position, we find velocity, right? If we change in velocity, that's acceleration. So think about this, right? The change in, right? I took the derivative. So if I want to find the change in velocity, what am I going to do? I'm going to take the derivative. So how do I take the derivative of this velocity function? Well, let's use a power rule again. So we're going to find actually the derivative of the derivative. So I'm going to call this x double prime, which is really what we would call just a of t, acceleration. So let's move our exponent down again. The 2 comes down in front, and that's going to be 2 times -6, which is -12. T stays, the exponent becomes 1, right? Because we subtract 1 from that 2. I don't need to put that 1 in there. And the 24, since it's a constant, that will really just turn into 0. So we can just call this -12t. That's my acceleration function. So I have my velocity function up above, and I turn that into the acceleration function by using the derivative. Sorry for my messy writing. So to find the acceleration at a time of 3, at 3 seconds, I'm just going to plug in 3. So I'm going to do a of 3 equals -12 times 3, which equals -36. And now the change in position is distance over time, right? Yards per minute. Is that what I put up here, or yards per second? Did I have the wrong label? Oh, I had yards per second. Let's call that, oh, I had meters per second. That was yards per second. Let me go back. Maybe somebody right now at home is like, Hirsch. All right. Yards per minute. So in this case, my acceleration is going to be yards per minute squared, right? That's yards per minute. So we square that minute. That's our acceleration. So if you want to just kind of review this again, change in position results in velocity. Change in velocity results in acceleration. If I want to find that change in, I want to take the derivative. Use your power rule. You can always substitute in to find that value at that time. Now it's really your chance to kind of go back in and try some of these. Now, what we did in class is we reviewed that, and then we actually moved on to a problem like this. So I give you the same exact problem, the same exact scenario with this dog moving back and forth on this horizontal line, moving left and right. But instead, I don't ask you to find necessarily the velocity at a time. Well, I start by saying, hey, what's the velocity formula? Which is prompting you to say, hey, that's the derivative. So let's just copy down our derivative from the last page. But then it asks you this. How do we find the initial velocity of the dog? Now this, you have to put in decimals. You're really copying stuff down. This is really just notes here. How do we find the initial velocity? Well, initial is just really a key word for start, right? Well, why is that important here? Because when I'm talking about our starting velocity, that actually gives us a value in disguise. How fast were we going at the beginning of time? So that means that our t has to be 0. So when I hear starting velocity, right, this velocity right here, I want to know basically what that's going to be when t equals 0, right? That's into my position formula. Sorry, I want to put those into my velo formula, right? t equals 0, what is my velocity? All right, let's do that work real quick. So we're going to say like v of 0, right? At a time of 0. Let's plug in and see what we get. -6 times 0 squared. You might be able to see where this is going, plus 24. And that tells me that v of 0 equals, well, 0 squared is 0 times -6 is 0. So we're just going to be left with 24. Okay. Now, what were we being asked here? Basically, how do we find the initial velocity? Oh man, I calculated. I didn't even answer my own question. Shame on you, Kirsch. Let's go back here. Let's actually annotate how did we find that. Okay, so when asked to find the initial velocity, we can substitute t equals 0 to find the starting velo. That's what I did. Starting, initial, time 0. So if I wanted to actually solve this answer here, right, v of 0, my velocity at 0 is 24 what? Well, let's think about our units. We have yards per minute, right, velocity. Okay. Now, how do we find when the dog is at rest? Okay, so there's these words are playing with our brain. We have to figure out how we get this information from the information that we have. Dog is at rest. What does it mean when a dog is at rest? It's not moving. How fast is it when it's not moving, when it's at rest? We have to be able to know that when they're talking about at rest, they're talking about 0, in this case, yards per minute. No velocity, right? 0 velocity, no movement. So how do we figure that out? How do we figure out, given this, when the dog will not be moving? Well, in this time, we want to know when the velocity is 0. So let's actually, I'm going to scroll up here and I'm going to kind of have some things that we got to erase here just based on, now they're all out of order. Annotations are a mess. So how do we find when the dog is at rest? The dog will be at rest when the velocity is 0. Okay, well, what part of my function actually stands for velocity? V of t does. This whole thing, my output needs to be velocity, right? Or my input is time. So if I'm using this equation to find out how fast, this entire velocity part is actually going to become 0. So what we're going to do is we're going to set the velocity equal to 0 and solve for the time. We're going to work backwards. They wanted to know when, right? When the dog is at rest. So our answer should be a time value. Let's do that real quick. I'm going to show you the steps. So we're going to start with setting that velocity equal to 0, and then we're going to leave everything else in there. Now there's 2 ways to solve this problem. It's a quadratic. I can think about factoring out a GCF, right? Factoring those things down into 2 binomials, right? Factoring. Or I can solve this one in terms of order of operations. So if I think about this, I would subtract 24 from both sides. So I get negative 24 on one side and negative 6t squared on the other. And then I would, let's see, what else would I do? I would divide by negative 6 next. So if I divide both of those by negative 6, I get 4 equals, the negative 6 is gone. So that's just t squared. And let's think about this. Come on, you can do this in your head. What times what, right? What squared would give us 4? Well, 2 or negative 2. You guys coming in here? You guys coming in here? Man, I'm recording a video right now. You want to be in it? Get out of here. And we know that we can't have a negative answer because there's no such thing as negative time. So we're just going to leave our answer as positive. We got a video crasher here. These guys, what you guys want to be in a video talking about velocity versus time?
Velocity versus time. What's the formula for velocity and time?
Well, I'm going to repeat that back to all the people at home. Okay, you ready for this? To take that velocity, we got to take the derivative. When we're looking for initial velocity, we plug in t equals 0. Now, if we're looking for when the dog is at rest, we plug 0 in for velocity. Do some work and get it done.
Hey, do your work, get it done. Pass that class.
That's right. You guys got practice now.